Alright, today we're going to be doing basic constructions. For this section, you will need a straight edge. By straight edge, I just need like a ruler. Okay, it's not necessary that we have any of the numbers, but it'll be important that we just have this straight edge on the end to use. And then you'll also need a compass. This is a compass. I don't mean like a northeast, southwest compass. I mean this guy. This is a geometric tool. Used to construct circles. Alright, so if you have never used a compass before, which I'm betting that most of you probably haven't, you are going to have to know how to hold it. Yours probably looks a little bit different than mine is, but if you hold it at the top, I'll just show you on the back of my paper, it works really, really well. Okay, another way I like to hold mine is by the bottom, right there. So you can also hold it like that. I'm a little used to doing it like that. Do not, this is how not to hold a compass. Hold it like this. Okay, if you hold it like this, it's going to go in and out, and you're not going to end up with a pretty shape. So you only need to hold it with one side. Okay, that side with the point on it. Okay, so the first construction we're going to look at is constructing congruent segments. So the first step in constructing these is just to draw a segment, one that you know is definitely longer than AB. Okay, so I know that one's at least the length of AB or longer. The next thing you're going to do is put one point at A and put the other point, the pencil point, at B. Okay, this is measuring your segment. You don't use a ruler to do it. We're using a compass. Okay, so then you're going to put it at this end point and just make an arc that goes through the end of that segment. So this will be the end point of your congruent piece. So we can call this CD, and here we know that AB is congruent to CD. Now we have constructed congruent pieces. If we were to measure this with a ruler, they should be the same length. Now let me ask you this. What if I want to construct 2 times AB? I can also do that. So to construct multiples of something, construct one that's the same length like we already did, CD, and then we can put it at that other endpoint and construct it again. What this does is doubles the segment. So now I can label this point E, and I know that 2 times AB is CE. Okay, CE is twice the length of AB. So that's constructing a congruent segment. Next, let's look at constructing congruent angles. So here we have an angle A. I want to copy that angle A somewhere down here. I want it to be the exact same measure. So the first step is the same. We're going to construct a segment at the bottom using a straight edge. If you don't use a straight edge, it's not going to be right. Okay. The next thing I'm going to do is using my compass, I'm going to make an arc that goes through both sides of angle A. And so that arc goes through both sides. What that is doing is creating a equidistant point on both sides of that angle. So now, using that same compass setting, you're going to come down to the bottom and make another arc. All right. Okay, your next step is to put one endpoint at your intersection and then move your pencil to the other endpoint. This is measuring the opening of your angle A. So we're going to come down here to our new angle, put the point on our endpoint, and make an arc. Okay, where those two arcs intersect one another, right here, that is a point on the other side of your angle. So I can use my straight edge to connect those. And mine is a little bit off, so I'm going to redo that. Okay. And so now I have two angles that are congruent. We'll call this one angle C. And I know that angle A is congruent to angle C. And again, if I wanted to do multiples of that angle, I could then just come up again and make another arc and connect that, and then I'd have twice angle A. Okay, moving on. Before we look at the next construction, we're going to define a few words here. The first is perpendicular lines. Perpendicular lines are lines that intersect and form a right angle. So for instance, these two lines are perpendicular. They intersect each other and they form a right angle at that intersection. So if we called this line L and line M, I could say that L is perpendicular to M. Okay, you can see that upside down shape. That means perpendicular to. Okay. All right, next we're going to define perpendicular bisector. A perpendicular bisector is a segment, line, or array that is perpendicular to a segment and bisects it. Okay, so it's got to be perpendicular to the segment and it has to bisect it. So that might look something like this. Okay, so that line L here is perpendicular to segment AB, and you can see by the marks that it also bisects AB. So now we're going to look at constructing a perpendicular bisector. This one is my favorite. So if you're constructing a perpendicular bisector, you're going to take your compass and stretch it out until you know it's at least halfway through AB. So I want it to be greater than that halfway distance. And then you're going to create almost a semicircle. Come down to the bottom and make a big arc on that side. Now you're going to put your point at the other endpoint, endpoint B, and you're going to do the exact same thing. You're going to make a semicircle there that goes through both sides of the other arc. And now you can see they intersect here. They also intersect here. Those are 2 points on your perpendicular bisector. So now if I connect these using my straight edge, I have a perpendicular bisector, and you can see it looks pretty good. So I know that this segment is perpendicular to AB. I also know that it bisects AB. Okay, so we'll have label that CD. So I know that AB is perpendicular to CD. These are both segments. And I also know that CD bisects AB. Okay. All right, last construction for the day. And what I suggest doing is rewatching this video and trying to do your own completely. That will really help. So the first step in constructing an angle bisector, we've already talked about these. Remember, they cut an angle in half. So that's what we want to do to this angle. We want to cut it in half. Okay, so we're going to start by taking our compass and creating an arc that just goes through both sides of the angle, just like we did when we were making congruent angles. Okay. The next step is using your compass. You can keep it at the same setting, or you can make it a little smaller if you want. It does not matter. I am going to take it, put it at this endpoint, and make an arc in the middle. Then I'm going to put it at where it intersects the other side, make an arc through the middle. You can see how those arcs clearly intersect at this point. That is a point on your bisector. So now, using a straight edge, connect vertex A to that point and your angle will be bisected. So now I have that segment, we'll call it AB, and it bisects angle A, cuts it in half. So ray AB bisects angle, let's give it 2 more points, C and D. So angle CAD. Okay, so that is the last thing in constructions. Again, I know that this is all brand new, so it may take you a little while and a little bit of practice to understand. We're going to come in tomorrow and practice the whole thing over and over and over again. Okay, just don't forget to bring a compass in class tomorrow. I have plenty of rulers that you can use.